Okay, 11 o'clock. Hi, Navneet. Can you hear me?
Yes, Aman, I can hear you. Can you hear me good?
Yes, I can. I can. Okay, so I believe we are live now, and we will be waiting for the attendees to join, anyone who is going to join the webinar. But I think probably it's going to be a good time to get started. So I believe everything is ready by your side, right?
Yes.
Okay. So, all right, let's get started. Everyone, good morning on a Saturday morning, and or maybe evening, depending upon where you are. We welcome you from the North India chapter of AIOUG in the webinar, monthly webinar. And this particular webinar session is going to be done by Navneet Upneja. Navneet is one of the co-founders of this regional chapter and has been an Oracle database, uh, consultant, Oracle database guy from a long time. So at the moment, Navneet is working, for a company called Oceaneering International Services, and he's working as a database manager as well as the middleware manager with that particular company. He's working with Oracle database and Oracle technologies for about 10 years, and doing lots of work in terms of business intelligence, middleware, and also in terms of application express. Besides, handling the job requirements and the job responsibilities, Navneet is also very active in terms of setting up the event like this one in terms of Ocean Yatra, Sangam, and all. He's actually participating quite a lot, and one of the key members in terms of the regional chapter, North India chapter. So this is going to be a session which is going to be about Dataguard, and this particular session is going to be in this particular session, Navneet is going to be talking about Dataguard and what exactly is going to be Dataguard, including the new things which are going to be there in terms of 12c. So without further ado, I will actually invite Navneet. Navneet, officially welcome now. So I
Thanks,
believe
Aman.
you are ready with the slide deck and everything, whatever you want to show to the people, right?
Yes. So let me
Okay,
just share my screen so you can just let me
please.
know if you will be able to see that fine.
Yes, yes, please.
Okay. So I just shared my screen. Just let
Yes,
me know
I
once
can.
you
I
see
can
that.
see your screen. Yes, I can see
Okay.
your screen. Can you make it a full screen, please? Can you just
Okay.
broadcast it?
What
Yes,
about now?
yes, it is coming up fine for me.
Okay.
So if all good, I think we are good to go.
Yep. Thank you very much, Aman,
Okay,
for the
maybe you
introduction
can
part.
just a small thing. Maybe you can switch off the webcam display. It is just going to save some bandwidth for you. If it is okay, then it's fine.
Mm, Let
Up
me
to
do
you.
that real quick.
Maybe you can on it when we're going to go for the QA. Then you can actually just enable the webcam one more time at that time.
Is it fine now?
Yeah, I think it's better.
Okay.
Okay, so I'm going to give it to you, Navneet, and I will be going on the mute. So all to you.
Okay. Thank you very much, Aman, for this introduction part and setting the tone almost correctly to start with. And okay, so good morning, everybody, to everyone. I hope everyone can hear to me good. So first of all, thank you very much, whosoever has joined on Saturday morning. And mostly people have a day off on Saturdays and spending our time just to listen to a guy like me instead of going out for some sort of movie time or some time with your friends. So thank you very much for that. So without taking much further time, I'll just come back to the real topic that we are going to cover for today's webinar. So my name is Navneet, and I'm going to talk about Oracle Dataguard for about 1.5 hours, and whatsoever I have done in my job or in my job role on Dataguard, I'll just try to share that stuff. So to start with my introduction part, so my name is Navneet Upneja, and I have a little over 10 years of experience in Oracle databases, and I have been working in middleware applications from last maybe 3 to 4 years. I'm a Oracle certified professional, having in hands-on experience on OLTPs, and then we have data warehouse in our environments. Apart from that, I have experience working on Oracle Business Intelligence, Apex, and few other reporting tools. Apart from my job that I do for my livelihood, I am also a co-founder of AIOUG North India chapters alongside Aman and Deepak. And we recently got Karan added to our team. So you can just follow me on my blog, that is navneetupneja.wordpress.com, and you can follow me on my Twitter, and you can see my presentations. I normally upload all the presentations on SlideShare. And you can contact me on my email ID, navneetupneja@gmail.com. So that was a brief introduction of me. So without wasting your time, I'll just go to the next slide and we'll start with the presentation. So in today's world, we have seen in last few years, there has been tremendous increase in the volume of data. And with increase in volume, the dependency of each and every individual to the organization is really increasing on what data they are seeing, what data they are sharing with others, and what data they are capturing from the universe. So if I simply talk about dependency of any organization on data, I can normally say that, okay, for every application that we have in the organization, from human resource to the financials, and if it's a supply chain or it's any other portals that we have, everything is basically talking to data. And through this data, these applications are basically talking to each other as well. That is what we call integration of data. With more and more data coming in, this integration between all these applications through data is increasingly becoming very, very important these days. So this is all where employers may be putting up their data into finance, or they are checking their salary data or other payroll data in human resource, or they are connecting to supply chain, or basically they are using some other third-party portals to access that data or insert that data. So that is what a normal employee in any organization would be doing that. And over top of that, you have a top management, a set of executives, VPs, senior VPs, looking at the statistics of those data, making all those important decisions that will drive the organization using just this data. So you may be using some sort of business intelligence tools, not necessarily Oracle Business Intelligence, but any business intelligence tools available in the market to just visualize that data. But what's important here is data. So all this is possible once you have that data with you. So while we're talking about this data, while something is important, so we have to secure that as well. And we have to be ready for, what if this data is not available, right? So let's assume, like, if in an organization you lose this data, so what will happen? So first of all, the integration that we were talking about, all these applications, all the functioning of this organization that was dependent upon all these applications that were accessing the data will be lost. And all these applications will eventually went into some sort of stale state where, whole work or whole functionality of the organization will come to a standstill. So while we are talking about importance of data, we have to, and we talked about, how simple loss of data can cause a integrated system into a disintegrated system. So we have to look into the aspect of what can cause this data loss, or what can actually cause this disaster. So the study that has been done worldwide, by some independent agency, says that 94% of time your data is secured. So if I say, out of 100, 94%, your data is not going to go anywhere. It will be secured. That's how the stability of IT systems have improved over the period of time. But there are still 6% of chances that you can still lose your data, or there can still be a data loss or a disaster with your data. So all these disaster recovery measures, or all these high availability measures that are coming to market, are basically to protect that 6% of data loss. So now, if we granularly see that 6% of data loss, under that 6%, what is causing the major of the loss? What factors are basically contributing to this 6% of loss? So we have one of the major factors is that account for 1.8% is human error, and the second most, you can say, over the top of the list we have is hardware failure. Other than that, there can still be a software corruption, there can still be an on-site disaster, there can still be a computer viruses that we recently see, and that then there can be little bit of, there can be cases where a theft can happen, someone can steal your data, but those factors really account for just 0.5%, and then computer viruses account for 0.4%, and on-site disaster basically account for 0.2% of data. So most of the chunk of data loss is basically caused by either hardware failure or it is human error. So now the rest of the presentation would be focused more on hardware failures and human error, how we can secure that data disaster in our organizations. So what we will see that to protect this 6% of data loss, what options Oracle provides us to, in terms of high availability and protection. So you must, if you are Oracle DBA and working in any organization, you must have heard a lot about Oracle Dataguard. So that is the topmost, you can say, the technology being provided, or most common technology provided by Oracle to protect your data. So under Dataguard, the most famous, or we can say is most common type of Dataguard that we are normally using is physical standby database. And we do have a logical standby database as well. Apart from that, Oracle has been improving, like every time they have been coming with lots of new features and functionalities over top of their basic offerings. So on top of Oracle Dataguard, Oracle has came up with Oracle Active Dataguard, where you can simply can see, not only you can have a replication of your data, but you can also do queries, or you can also do a reporting on your database. So you have a read-only physical standby database available to your disposal, which is basically in sync with your primary, and at the same time giving you an ability to report over top of that. Apart from this, under Oracle High Availability, you do have Oracle Golden Gate, which is sort of an active and active read-write logical standby database. And then you must have heard about Oracle RAC, which is more of a Oracle High Availability thing rather than a protection. So it's a main high availability option provided in the data center by Oracle. So for this presentation, the scope of this presentation would be lying on Oracle Dataguard, which consists of physical standby and logical standby. So normally whenever I talk about Dataguard, I just love to call Oracle Dataguard as insurance of your data. And whole sole reason to call this as an insurance is because in our daily life, or in our human life, we always insure our precious thing. So unfortunately, I believe so, there's no company available in the market which actually provides a sort of life insurance or any insurance to your data. So in terms of protection and data security, the software and technology that is available in the market is in case of Oracle, that is Oracle Dataguard. So I just love to call this as an insurance to your data. So what Oracle Dataguard is? So what Oracle Dataguard ensures is a high availability of your data. So let's say, like, if you lose your primary in case of a disaster, you still have your standby database if it's configured correctly at your disposal. So your company does lose your primary, but doesn't lose the data actually. So you still have a standby side to fall to, and it does provide data protection and disaster recovery for enterprise data. And then it's basically a comprehensive set of services that can actually create, maintain, manage, and monitor one or more standby databases. So with Oracle Dataguard, it's basically making your job very easy, just to create, maintain, and manage multiple databases, multiple standby databases at the same time. One important part here is, like, all these standby databases are managed transactionally. So any transaction you are doing on primary, or it's being carried out on primary, it's being carried over to standby as well. Depending upon the configuration, means how fast it is carried over or how fast it is applied, it depends upon the configuration that we are going to talk in a little while. Then very important functionality of Dataguard that it provides is a switchover for planned maintenance. We all are aware of how hard it's to take a planned downtime for any of critical production systems, and without actually impacting the business of the organization. So this with Oracle Dataguard, we do have an option of a graceful switchover to a standby, where the time that your application will be unavailable depends upon the time you will basically switch over to standby, which is in few seconds. With a recent study from Oracle, when they started with Oracle Dataguard in 9i, the switchover time that they've started was 52 seconds, and that has been basically drastically reduced to 19 seconds or less than that in 12c. So another feature is failover, for which this is the condition, the 6% loss that I talked about in the beginning of the presentation. The failover thing, when you have an actual data loss and you actually have a primary side going down, you can basically do a failover to your standby, and the time it takes to do a failover in 12c is as less as just 8 seconds, which actually started with 28 seconds in 9i or 10g. It is reduced to now 8 or 9 seconds in 12c with all the improvements in the technology. So what Dataguard consists of is one production database that I normally call it as a primary database, and then it do consist of one or more standby databases. And it's so when we say, like, you have a product primary database and a standby, and they need to be replicated at all the time, definitely they must be having some sort of connectivity in between them. So that connectivity is maintained by Oracle Net. No restrictions on where databases are located, provided they can communicate with each other. Operates on a simple principle, that is ship redo and apply redo. So as long as your system is able to ship the redo and standby is configured, it should be able to apply the redo as well. So it's a very basic mechanism where you have to send something and the other party has to receive that and apply that. So in a basic configuration of a standby database, you will see that on the left side of your screen is your primary database, and on your right side of the screen is your standby database. And these two sites are geographically at two different locations. So what this process is trying to show is, in your common or in your general setup, anytime you are doing anything on the primary database, LNS process is reading all your changes from the read log buffer and sending it over to the RFS process on a standby site, where RFS in turn is applying all those changes into SR logs, means standby read logs, and then in turn it is getting applied to a database using an apply service. So it's a very basic setup of any standby database. So in a normal standby database, while you are setting it up, you just need to do a very minimum configurations on both sides of primary database as well as standby database. So a very important thing that is required in primary is that you have to have force logging enabled on your primary database. It's not basically a necessary thing that if you don't have that and standby will fail. No, it's not a necessary thing, but it's a recommended thing. So anytime you have certain operations running with no logging option, let's say you rebuild the index or you created a table with a no logging option, those operations will not be recorded on a standby if you do not have force logging enabled. So it is highly recommended, and just take it as a sort of a prerequisite thing that if a primary database has a standby database, you need to have force logging enabled on the primary side, just to have both the databases transactionally consistent. Then you have a important parameter, that is log archive config, which basically defines that what all databases are participating in the configuration. So the first database name, the first database that is mentioned in this parameter is the primary database ORCL, and then you have a standby database name, that is ORCL-DB, which is basically a DB unique name of your standby database. Apart from that, you need to tell primary database where to send the archive logs, or where is my standby, that is defined by log archive -2 parameter, and you define it as a service. Service is basically nothing but a alias name given to your standby database in your TNS names.ora file, and the rest of the thing, no affirm and async, is the type with which your redo data from primary will be transported to standby database. And apart from that, you do have a file server and TNS entries that you have to make. So TNS entries means you need to ensure that on your primary side, TNS names.ora file does contain an entry for your standby site as well. So while creating this database, you need to back up your primary database. So what Oracle believes, or what Oracle ensures, that your database needs to be in an archive log mode before you can basically start the setup for standby database. So that database needs to be in archive log mode, and then you take a backup of your primary database and do add your standby redo logs. We'll discuss the importance of these later in the slides. Apart from this, means these are the settings which were done on the primary side. These now we have a few settings that we need to do on the standby server. So we do need to copy. It's not a mandatory step. If you can write your own sort of parameter file, a new parameter file on standby, it is fine. But if you're lazy enough to write all the parameters, you can simply copy your parameter file from primary to standby side, and then you need to change the required parameters. Definitely, you need to remove, or just need to remove all the parameters which are just defined for physical or primary side. You need to enter new parameters for standby, and the most important parameter is to change the DB unique name. So what we have to see here is database name. The Oracle SID will remain same as that of your DB name will remain same as that of your primary, but your DB unique name, you can change it to a different name with which your standby database will be identified in the environment. So, and then you have to give false server, which is basically pointing to your primary database. And you do need to mention what is the location for your archive logs on your standby. That is really important, because that is the location where your archive logs on standby would be received and saved. So you can define that parameter using log archive -1. In case of switchovers and switchovers, basically, you need to send your redo back to primary. So it is an optional parameter, but you can set if you want to do if you plan to do a switchover, or if switchover is a part of the activity that you do in your organization, you need to set a parameter that points to the primary site or the primary database. I just use that log archive -2. You can use -2, 3, 4, anything that you want to do. And you need to mention the service is equal to ORCL, which is my primary database in this case. Once you are done with your initial prerequisites, which include P file, setting all these parameters, all the directory structures created on the standby side, then the easiest way to create your standby would be to ship the backup from your primary to standby and use that rman backup and use rman duplicate command to create your standby database. So it's as easy as, once you have all the things ready, all the prerequisites done, you just need to run in a duplicate target database for standby. You'll notice that while I'm using this duplicate target database, or in a general case, while we are cloning a database, normally we do provide a name for the database, the name to which we want to duplicate or the name of the database that we are going to create. In this case, I just have to mention for standby, and what it will check is that whether you have a backup of a control file in a standby format. So while you're taking a backup on primary, you need to have a backup of a control by for standby, so that can be restored as a standby control file on the standby site. Other than that, there is no change. You just provide your standard parameters for DB file name convert. If you have a different locations, if the name or the path of the files, data file, is going to be different from what you have in the production, it's safer to provide DB file name convert. That will actually tell Oracle to set the new names for your data files in the control file, and same goes for the log files as well. So once you do that, it will just create a standby database for you. So that was a basic setup that I just explained about standby database, and most of you must have seen this thing, or you must have came over this process in your organizations in your day-to-day routine work. Now we'll see what are the most common types of standby databases that we have. So when we say most common, doesn't mean that okay they are not useful. So when I say most common, it means like the most useful and mostly used standby database or type of standby database that we have in Oracle is physical standby database. So as the name suggests, physical standby database is an exact physical copy of your primary database. So if I have to explain to someone that how it is physically same, in a very sort of a layman language, that if your physical primary database is of 100 gigs, your standby database will be 100 gigs, right? Because it's a physically maintained copy of your primary database, which is an exact block for block copy of your primary database. Your physical standby database is basically maintained through a process that is called redo apply. So as the name suggests, redo apply, this type of a standby database is receiving a redo stream from your primary side, and this redo is being applied on the standby. So all the changes that are being done on primary are copied over in the form of redo on the standby, and then as it is, redo is being applied over the standby database to make it in sync with the primary. So redo received from the primary is continuously applied to a physical standby, and this physical standby can be opened in a read-only access mode. What that means is you can open your database, standby database, in a read-only mode, and in fact you can use this database for many other purposes, like taking a backups of a database, or you want to have some reporting server, or you have a BI which wants to access data for production. You can simply point that BI to this standby database and access data. Another over top of this read-only access, there's another feature that, or what ability your Oracle gives you, is that your redo apply can still be active while your database is open, which is really huge sort of improvement if we talk about what new things happen to Oracle Dataguard. So, and you can have an open standby database, and that is applying redo. So you have a real-time access to your, or real-time view of your data sitting on your standby side without even impacting the performance of primary database. And that is possible with a new sort of, that was, which is not actually new now. It was introduced in 11G. So that is called Active Data Guard. Only point is that you can use this. If you want to use this, you need to have an additional license for this thing. If you are not using Active Data Guard feature, the other Oracle Data Guard license comes with your Oracle Enterprise Edition license. So you don't have to pay extra for your Data Guard license. If you are going to use Active Data Guard, yes, you have to pay for that. Another sort of famous, or you can say that another type of standby database that is available, or that is made available by Oracle from the beginning itself, is logical standby database. So yes, it is different from sort of physical standby database, but it is also a standby data. Since it is called a standby, it means it is also an exact copy of your primary. So how it is different from physical, if it's an exact copy of a primary, is the first difference comes from how the changes from primary are applied in a logical. So in physical, we were applying a redo, but in logical standby, we will not be applying a redo to the standby databases. And instead, we would be, the database would be fetching the SQLs, or it would be generating the SQL statements out of the redo stream it is getting from primary, and then would be applying the SQL using a SQL apply. So these changes are more of a, if you are doing, let's say you are doing a DML activity or a DDL activity, it is like you are running some sort of commands or SQL commands on the standby databases and making it in sync with the your primary database. And this logical standby, what extra it gives you over the physical is you can open the logical standby in a read-write mode, right? So common question that I have been asked over the different presentations that I give on this, that is like, if we are opening a logical standby database in a read-write mode, how we can ensure that it remains consistent with the primary database. So the tricky part here is that you can do a write operations in logical standby database, but on the objects which are not being maintained by the SQL apply. So anything extra, let's say if I have 10 schemas in primary side, those 10 schemas will remain sort of a read only in your logical standby. What you can do is, if you create an 11th schema directly in a logical standby database that is not been there in the physical side, you can do all your normal database operations over top of that. But since it's a SQL apply, not a redo apply, that will still remain, the other 10 schemas will still remain in sync with your primary site. So the thing is that the tricky part is to protect the data set that is being set to maintain by a data guard. So this is one of my a favorite thing that I always that has been really useful to me in my organization, and we have been able to achieve a lot and do various operations using this, and that is called Snapshot Standby Database. So Snapshot Standby Database is not a sort of a third type, but it's basically subtype of a physical standby database. What's important with Snapshot Standby Database is that it allows you to do a read write on your physical standby database. So it may sound like I'm running away from the definition of physical standby database, which says that it can only be opened in a read-only mode. And now I'm saying we are able to do a read write. That's basically the tricky part, or you can say that's the X factor with Snapshot Standby Database. So Snapshot Standby Database is also known as updatable standby database. This is an additional feature over and above your physical standby database. This database can be open for read-write operations while redo apply is stopped. So the important part here is that you can do your read-write operations, but during your read-write operations, if your database means you have opened a database in read-write operations, during that time, the redo coming from your primary cannot be applied on the standby database, since your standby is in read-write mode and it's physical, not logical. While your standby is in read-write mode, it cannot do a redo apply, but it can still receive redo data from the primary side and store them as an archive logs. So Snapshot Standby Database is like we have to convert our physical standby to a Snapshot Standby, and what internally it does is it uses flashback and granted restore point mechanism to perform the action. It is really useful while you are doing some sort of testing, when you cannot do that testing in primary. Let's say your primary is really overloaded and it's a production time, you cannot you have some sort of data loss, or you have some issue in primary, you want immediate fix. You can't have a clone of your database because the database is that huge. It takes multiple hours to create a clone. The simplest way is just to convert your physical standby database into a Snapshot Standby database. What additionally we have to do is we do need to maintain your flash recovery area, and that has to be adequately sized for that. So in the next screenshot, you will see that this screenshot is from my primary database, where control file type is standby, which is very normal thing, and I do have flashback disabled on standby. And you will on the top of the screen, you will see that I do have a DB recovery file desk parameter set to a location on my host, and I do have assigned 20 gigs to DB recovery file desk size. So what does that mean is if my flash recovery area becomes active or becomes in use, I can save 20 GB of files or data in that location, in that particular location. So to convert your physical standby database into a Snapshot Standby database, what you have to first of all do is you have to cancel the managed recovery. So in the first command, what I have done is I have just used alter database recover manage standby database cancel, and then once that is done, I have to just enter one single command saying alter database convert to Snapshot Standby, and that's it. And you'll see that once you get a response saying that okay, database is altered, you can query your VDollar database to check the control file type and flashback on, and the values for which was standby and off earlier are now for control file type. The type is now current, which says that this control file is now current and can be opened for read and write. and then you have restore point only value for flashback on, which suggests that flashback is still off. We are still not using flashback technology in itself, but what we are using is we're using a grunted restore point, which is very evitable. If we see, if we just take a look at alert log of the operation that I did, you can see that when I converted my physical to snapshot standby, internally what it did was it created a restore point called as snapshot underscore standby underscore required, which says that this snapshot standby point or this grunted restore point cannot be deleted, and it will be there for the time being until I basically switch back to my physical. And in the below, at the bottom of the screen, you will see that I went to the flash recovery area location that I defined in the parameter, and there are a couple of logs which are generated for the flashback. And more the work that you will do in this while the snapshot is open, and you'll do some DML activity or DDL activity or anything that is being changed, you will see that these logs will grow here. Means you will have more logs generated on this location, and it is limited by the parameter flash recovery size that I defined it as 20 GB. So until and unless or as long as I have enough space in here, I can do all the testing and changes in my snapshot standby database. So once basically I do go back, or I convert back from snapshot to physical standby database, what internally it will do is it will simply roll it back. It will use rollback functionality of flashback to roll back to the point before this grunted restore point, and these generated logs for flashback will automatically be deleted. So you don't have to manually manage and delete those logs and worry about these later on. These logs will be taken care by Oracle itself. You don't have to manually take care of these. Okay, so while we are talking about standby databases, whether it is physical standby or it's a logical standby, so the question that comes, or normally you will be asked by a manager or other management people, does this have an overhead? And normally people who would be worried about these would be infrastructure guys or network guys, because ultimately we will be utilizing their resources to manage our standby and primary databases. So a simple answer to that is yes, but we have to decide what is more, can we actually what is more important? It's the overhead or the protection and the features that we are getting, the extra ability that we are getting by setting up these standby databases. So yes, the simple answer to this question is yes, but what we are getting in return of this is much bigger than the overhead that we are basically going to see on our systems. So the only overhead or the things that are going to impact while using these standby or Oracle Dataguard functionality is your network and IO. So we have seen in the initial diagram of standby that it uses Oracle Net services to send a redo stream over Oracle Net to a standby. So if those two locations are dispersed globally at two different locations, that's going to use the WAN setup of your organization, and depending upon the bandwidth and what's the capacity of that setup that or network that you have, it's going to decide what type of or how much impact this setting up of standby database will have on your sort of setup. So answer is yes, but it is the overhead is we can decline, or we can simply have this answer saying, okay, the benefit that we are getting in standby is much more than overhead. But apart from this overhead, what we also have to decide is the protection methods and redo transport methods. So we can basically work on these things and decide on what protection methods and redo transport methods we need to have in organization depending upon the data that we are protecting. Let's say if I am into a banking sector, I am a DBA in a banking sector, and where my manager or organization management says we have a SLA of zero data loss, right? Then you have to decide your protection method and redo transport methods accordingly. But if I am in, let's say, manufacturing company, where they can still have their business is not 100% dependent upon the transactions that are going into the system, or at least the transactions that are going into the system can easily be replicated, even if they are lost to a certain extent. Yes, then you have to decide on the protection methods on a different sort of scenario. So you have different scenarios while you need to select your protection methods. So we'll see what all protection methods that we have. So first of all, the most protected method that Oracle provides is maximum protection mode. So as the name suggests, it's this. If you have this method, maximum protection mode enabled for your primary and standby database setup, so this is the most secured method that you can have for a Dataguard setup. Standby database using this method is always in sync with primary. When we say always, it means that it doesn't have a delay of even 1 second. And basically with protection mode, we do not count for the time, we count for that transactions. So with this method, you can ensure that there will be no transaction on the primary can actually be successful without that transaction is also there in the standby. So you always have one-on-one dependency and one-on-one in sync between primary and standby. So it uses sync method of redo transport, which means that the redo generated at the time of redo generated on the primary has to be shipped to a standby site in a synchronous way. In this maximum protection mode, primary database will always wait for an acknowledgement from the standby site that it has actually received the redo and written into a standby redo log files. So when we say that it's a protection, that is how it is providing a protection. So it will not commit any transaction on the primary site before it has actually written it to the standby and received an acknowledgement from the RFS. In this case, RFS process is basically responsible for sending out the acknowledgement to LNS, which further basically sends the acknowledgement to your LTWR, which in turn do a commit for the transactions. In case of failure of standby site, since we are talking about protection mode and you do not have a standby site, or there is a failure in standby site, primary database cannot go or cannot move further. It has to go down. So you will see that your primary database is getting terminated, shut down if your standby is not available, or it's for any reason, whether it's a network disconnect or if it's a hardware failure on the standby side. When primary database cannot connect to a standby in protection mode, maximum protection mode, it cannot function. It cannot go ahead of that, right? So that is how it is ensuring that you will always be 100% protected, even though your operations will come to a stall, but you are not compromising on the protection of your data. And this mode will always have an impact on the performance. If this is the mode which will require best of your network, best of your hardware to have a maximum performance on the primary side, because you are always dependent upon the external server, which is not the same server on which your primary database is. So depending upon how fast your network is, how fast your hardware on the standby side is, that will decide what performance you get, or how much impact on performance will be there on the primary side when you are running your standby database in maximum protection mode. So if we diagrammatically see how protection mode works is, so on the left hand side of your screen, you do have your primary setup, and on the right hand side, you do have your standby setup. So let's say if a user commits a transaction, so immediately you will see that there will be buffers going into SDA, and there would be a redo stream generated in the log buffer, which will be read by LTWR and will be written to online log files, right? While this is a normal process, but if you have your standby database setup into maximum performance mode, what additionally it will do at the same time, your LNS process will also be reading it from the log buffer at the same time when your LTWR is reading, and will be sending the same redo stream to RFS on the standby side through Oracle Net Services, which will be written to standby redo log files. Once it is being written to standby redo log files, RFS can simply send an acknowledgement back to the primary side to LNS, which will send the acknowledgement back to LGWR. Once LGWR will receive the acknowledgement saying that, okay, the logs has been safely recorded in the standby read log files, then only LGWR will send the commit acknowledgement to the user session. Till the time this is not, LGWR does not receive this acknowledgement from RFS, user session will keep on waiting on this, on the response. Means if it's, let's say if user has ran an update statement and there's a delay from the standby and done a commit, that commit will not, you will not receive commit complete until LGWR basically receive acknowledgement from RFS. The second most protected mode that Oracle provides in Dataguard setup, or what I can say is second most protected, but little less protected than the maximum protection, is maximum availability mode. So what maximum availability mode gives us is same functionality of what protection mode gives, but with a star mark. So the star mark that I say, it says that it will be providing the maximum protection to your standby database and to your primary database as long as it can. So it is it's sort of a granted with a star, right? And then in the event, so when it says it can do a maximum protection mode, definitely it will also wait for the acknowledgement from the RFS that the changes has been applied. But in case it is not receiving the acknowledgement, the LNS process on the primary side will wait for a certain duration of time, and that is defined by net_timeout parameter, right? So once your LNS has waited for the duration defined by net timeout parameter, let's say 30 seconds, right? And it will basically it will send a message to LGWR saying that we have waited for 30 seconds and haven't received a response. So you can basically go ahead and commit the transaction. So in this case, Oracle has tried to remain in maximum protection, but because of some issue, let's say there was a network disconnect for 15 minutes or so, it converted into maximum availability mode. So what it does is it says your primary will always be available, irrespective of whether standby is there or not. But with a star mark saying that the Dataguard setup will try to keep you always in maximum protection mode, given that you need to have your network and connectivity and your standby setup always available, right? So the extra benefit that we are getting, or the security that we are getting in this case, is that your primary will not be getting down, or it will not be shutting down or terminating in the event that your standby database is not available, right? So do we have a data loss here? Yes, we do have. But to us, that data loss will depend on the level of disconnect that you have from the standby. So it's not something that it is data loss can be avoided, but yes, that data loss will be very minimal. So in this maximum availability mode, it will still use sync method of redo transfer that maximum protection mode was doing. So it is doing the same thing. It is when it can send the acknowledgement back, it would be sending that. But in case this acknowledgement is not sent, it will wait for the net timeout parameter and send the acknowledgement to LGWR saying that you can go ahead and commit the transaction. Okay, so do we have anything extra in 12c that has to offer for maximum availability? Yes. So in this case, what we have seen is it is using a sync method of sending the data, and it's basically use sync affirm, means that you always has to wait for the acknowledgement from the RFS, and that acknowledgement will come once RFS receives and writes the data to standby read log files. So you still have a performance impact if your writing to a standby read log file is slow. Let's say you have a slow sort of storage than primary, right? So your acknowledgement depends upon how fast your RFS process can write to standby read log files, right? So over top of that, what Oracle gives in 12c is fast sync. So you can, in this method, you can still avail the offers or avail the functionality of that is available in maximum availability, but again with the second star mark. And the second star mark is RFS doesn't have to wait to send acknowledgement back like a maximum availability, that it has to wait for the redo to be written to standby read log files. But instead, what it will do is it will send the acknowledgement back as soon as it gets the redo stream. So once RFS receives the redo stream from primary side, it will send the acknowledgement back to LNS saying that, okay, we have received the redo stream that is sent, and you can actually go ahead and commit that transaction. So in this case, primary has to rely on RFS, thinking that, okay, anyhow, if RFS has received the redo, that redo is safe. So the changes that are received by RFS will not be lost. And if we actually go back into setup of standby, it is true to a certain extent, because if RFS has received the redo, and for any case, if it's not able to write to the standby read log files, anyhow, in that case, it would be writing the redo to archive log files. So you probably may not have a sync method going on the standby. You can still have the async method, right? So your data is still secured, and you will have a gain in performance on the primary side, given that you don't have to rely on the IO speed of the storage that is there on the standby side. So your primary will still be operating in a maximum sort of performance thing, but still with the features of maximum availability and maximum protection as well. So this is something that is new in 12c, and till 11g, you were having two options for the log XPT mode, that was sync and async. So now with 12c, you can actually set it to fast sync, and that is only applicable for max availability. It cannot be done for maximum performance, and it cannot be done for maximum protection as well. So do we have a performance overhead in here with fast sync? Yes, we will still have the performance overhead, but it would be pretty less than what we used to have in maximum availability and maximum protection mode. Right, so another new thing over top of this maximum protection and maximum availability in 12c is fast sync instance, right? So you can still argue that we still want to be in maximum performance mode, but we can't afford, the network speed that we had, it's going to remain same. The IO speed that we have on the standby side, it's going to remain same, because if you want to do a change, or if you want to have a better storage, you need to replace your whole your storage. So whether your company or organization can afford that, I don't know. Means if they can, it's pretty good. You can definitely recommend that, and you can simply operate in maximum protection mode or maximum availability mode. But what if you can't afford that, but you still need to leverage the functionality being given by maximum protection mode? You are working in some sort of banking or telecom or a really mission critical database that you cannot afford to lose a single transaction as well. So the easiest method, or another option that 12c provides you is fast sync instance. So if you see, means I'm not calling this as a fast sync database, I'm just calling it as fast sync instance. And this is new in 12c. So the reason to call it fast sync instance and not database is because it's not a database, it's just an instance. So when I say it's not a database, this means that it doesn't have a data files. It doesn't have redo log files. What it does contain is just control files, a parameter file, and standby read log files. So those are the things, those are the things like parameter file and control file are the minimum thing just to start your instance, right? So once you have that on your fast sync instance, that machine can be little bit closer to what you have, closer to the location of your primary database, and working in sync affirm mode, that is your maximum protection mode. And that's it. Means you can have a fastest of your network working for fast sync. And how if you can see this picture or diagram, what I have seen is on the leftmost side, I have a primary database. On the rightmost side, I have a standby database. And in the middle, I have another location that is fast sync location. Now, that location can be really close to a primary database, not necessarily that close to a standby. Let's say if my primary database is in Houston and my secondary database is in let's say in Washington, right? And that is pretty far locations, and you cannot afford, or you cannot basically have that protection mode running in between these two locations. But unfortunately or fortunately, basically you have a mission critical database. You can't afford to lose a transaction. So you can basically decide to have a third location where you can have, which is pretty near to your primary, let's say Houston, let's say Dallas, which is few miles away from Houston. You can create your fast-sync instance there, and you can have your fastest of network between those two locations, given that they are geographically very close, and run that in a maximum protection mode. So since you are ensuring that you have a maximum network speed and a maximum network performance going in between these two locations, you can be pretty much sure that your primary will not have to wait for redo to be written on the fast sync. So what fast sync is giving you in here is, it is receiving data from primary and writing it to SR logs. That those are your standby log files, right? And if required, it would be creating, depending upon the performance mode or protection mode that you have between fast sync and standby, it would be creating the archived log files if required on the fast sync as well, right? So in this case, what I can say is fast sync is receiving redo from primary, right? Let's say in a sync mode, it is sending your redo to further to a standby database in async mode. That is quite possible, right? You do have a slower network, or not that fast network between fast sync and standby, but you have a fast network between primary and fast sync. You can afford to have a high protection mode enabled here, and between fast sync and standby, you'll be working in a maximum protection mode, maximum performance mode, sorry, right? So in this case, on the above, on the top of the screen, you'll see that this blue bar, it says is you still need to have a network connectivity between primary and physical standby. Although you do have a connectivity of primary to standby through fast sync, you still need to have a direct connectivity as well. So why this is required? So let's say you get, on a day, you lose connectivity between primary and fast sync, right? But the connectivity is still there between primary and standby. So you don't have to do anything. It will automatically be, primary will start sending read logs automatically to standby database in a maximum performance mode, not in the production mode, since you have a slow network there, right? So it gives, on one side, it is giving you, the features of maximum protection. On the other side, it is also giving you a high availability for the standby as well. So if in case your fast sync go down, you still have the standby database intact, right? One thing with fast sync is that the license for fast sync doesn't come standard with your enterprise edition. So it comes with the active data guard feature. So if you have active data guard license, you can use the fast sync license. You don't get an extra license if you have active data guard, right? Okay, so the next mode and the last mode that we have in standby is maximum performance mode. So this is the mode, at least I have seen maximum to be used, or mostly to be used in the all the production sites that I have worked on. So if you create your standby database or data guard configuration, that this is a default mode that would be enabled by default between primary and standby, and it has a minimum overhead on the primary database. I said minimum overhead, I didn't say no overhead, because it still need to use your network to send your redo stream from primary to standby, right? So the most important part why it is maximum performance mode is primary database does not have to wait for standby database. So here primary is working independently and standby is working independently. Although they are connected, they don't have to wait for each other. The method to send redo is async. It is not sync, right? I'm sorry, I believe I have a spelling mistake here. I'll rectify that later. So it is using an async method there. In this maximum performance mode, the LNS process on primary will try to keep standby in sync with primary as long as it can do. So, but in case your redo generation is more, the rate of redo generation is more on primary than the speed at which LNS can read and send data to your standby, in that case LNS will fall back. It would always be lagging behind. but that lagging will automatically be handled by the standby process, by the LNS process and the RFS process on the standby side. So once it is not able to do that, it will just fall back and will do an automatic log gap detection and will fill up the logs. And it's been mostly being used. So in standby database, you will see that standby site is working independently, and LGWR doesn't have to wait for any acknowledgement back from the standby site. So that's how it is maintaining the high performance on the primary. So it is just consuming, it is just using the resources or to the best of the capability on the primary, and doesn't have to wait for anyone. It just works independently as if there is no standby, and the process of standby would be working independently and not in collaboration with any other process, let's say LGWR. Okay, so this is a nice feature or a new feature in 12c, which actually gives you how ready you are for a failure. So all these slides that we have gone through, or all these stuff that we have been reading or implementing in primary, is for the situation where we have to fail over or we have to switch over. So how often we do that? If I talk about failover, it is, I believe, like it would be really 0.001% that we actually have to do a failover thing, but we have to be ready for that. So how we can test that? There was no method to test apart from manually testing all that stuff in actual, but 12c gives you a new command, that is validate database, to test your readiness for the switchover or for the failover thing. So what you have to do is you have to connect to your DGMGRL, right, GRL, and simply write a command, validate database and database name. So you can write a database name as your standby database, or you can write give a name as primary database. What it will do is it will check all the, it will basically check the prerequisites required for a switchover or for the failover thing, and will give you come back with the status. You'll see that I ran a validate database for my standby database. It does provide me that, okay, this my Apex test SB is the role of this database at this moment is physical standby database, and for this my primary database is Apex test. Now, in another section, it is giving me whether my database is ready for switchover. Yes, it is ready, right? Means I do have all the prerequisites checks and in place. So in case I have to do a switchover, the switchover probably would be successful without a failure. And in case I have to do a failover, yes, I'm ready for the failover as well, right? So it does gives me an overview whether whether flashback is enabled on any of my database. On primary, no. On standby, no. And then if it gives me status of the redo log files and standby redo log files as well. So in this section, it is giving me number of redo log file groups that I have on the primary and standby redo log groups that I have. And then since going by the Oracle convention that if you have, let's say, 5 read log groups, ideally you should have 5 + 1 standby read log groups. So going by that formula, I am basically, less than that. I'm having 3 read log groups. So it is giving me that number of standby read log groups that you have are basically insufficient, right? And same it does for standby as well. So on standby as well, it says you have 5 online read log groups, but you do not have a standby read log group at all. Right, so it's 0, and it's giving me a warning also that's saying that standby read log groups not configured for thread 1 on Apex test, right? So it's quite an impressive thing. So if it doesn't, I'm not saying it may be 100% accurate or you have to 100% rely on that, but certainly it can basically highlight important things that are required or that are prerequisite before you do a switchover or you do a failover thing. So it's something that is good, that is added in 12c only. Okay, so all these things that we have just gone through, whether it is physical standby database or it's a logical standby database or any other thing, all these things actually cover the one part of data loss. So if you still have a picture in mind that we saw in the beginning of this presentation about data loss. So two most common factors, or the bigger factors which were accounting to data loss, were human errors, and the second one was software or hardware failures, right? So in case of hardware failures, so whatever we have covered right now covers the hardware failure. I mean, if your primary hardware got failed, or if, let's say, there is a power failure on your primary side, or suddenly you got a disk corruption on your primary side, and anything of this sort which is damaging your hardware at all, hardware in that sense, you can simply or safely switch over to your standby database and safely point your applications to standby, and you can still operate your operations, right? But what if you have a second most common error, that is human error? Since we all are humans and we are basically tuned to make mistakes, so we are always trying not to make mistakes, because there is always a possibility that we can make a mistake. And since we are humans, that is very common to each and every human. So let's say you have someone, let's say a developer or a DBA, accidentally ran a truncate table command, or let's say a drop table command on your primary database. So since it's a DDL, and or it can be a DML as well, in case you are running some delete commands or something else, right? So your standby setup doesn't understand that you are making a human error. So for standby setup, it is just another DML statement or just another DDL statement. So by going by the logic or going by the functionality, standby has to have to basically apply those changes to the standby as well. So in case you do not have that delay thing on your standby, right, that would be immediate. So since let's say you are working in maximum data protection mode or data availability mode, those changes would be immediately applied on the standby. So your table is lost on the primary, same time it is lost on the standby as well. So what are the options to recover that? So there are multiple options that are there, but every other option has some sort of overhead or some sort of physical sort of effort or manual effort attached to that. Let's say you drop a few tables and you have a backup. You can decide to do a recover table command if you are luckily on 12c, but that do require, if that table space size is, let's say, 500 gigs, you do require 500 gigs of extra space for Arman to restore the backup and restore the table space for you, and then get the table out of that, right? But if you do not have that, that option is not available to you. The other option is to, if there are multiple tables and those tables were really important, and the only option that is left for you would be, to roll back or sort of do a point-in-time recovery. That is again a costly process where you are basically taking your database back in history. You maybe, if that table was lost, let's say 2 hours back, so you are basically compromising on 2 hours of transactions that must have went into your system, right? So how standby is, if you have a standby setup, or if you have Dataguard setup, how it can help in human error is through flashback. So flashback is another a sort of a powerful tool, which I always feel that is underutilized, or it is underrated tool that is provided by Oracle. But if it's being used in a pretty smart fashion, it can really be a life-saving for many DBAs and for many organizations, right? So the beauty about flashback is you can enable flashback just on standby database, right? So when I say just on standby database, means you don't have to basically enable your flashback database on the primary side, right? You can still have your primary running in best of the mode you want, without any overhead of anything extra running on over top of that. But you can still afford to have a flashback enabled on your standby database, and that too without any extra license, right? You just need is enough space and enough resources on your standby database server. That's it, right? And while you're enabling your flashback on standby, you don't need to do any change on the primary side, right? That is more important. So if you have your flashback enabled on your standby side, if you understand what flashback do is, and by the name of itself, flashback, if in case of a human error on the primary, that is replicated to standby as well, In that case, what standby extra is doing is it is capturing that change as well. It is capturing the previous state of that change as well. So if you are truncating a table with flashback on, it has a flashback logs for the table with the data as well. Or in case of a table failure, it does have table in the flashback logs as well. So what flashback will enable you is to go back into the time. In case of a table drop of a table, you can simply do a flashback before table, or you can run that command and it can be restored for you, right? And then in case of you truncated the data or you deleted the data, you can always go back into time, just assuming that at what time that script or that command was run on primary. You can go back to a time and recover your data as well without actually impacting your primary, right? Means you are not making any change on primary. What you are doing is just doing the operation on standby without touching your primary. So once you have that data back in standby database, you can use standard techniques of import export or import data pump technologies to export the data and do whatever you want, right? So reset logs on primary, no. In case you do not have flashback on standby, certainly you will end up doing reset logs on primary if you go back into time. But if you have flashback, no, you don't need to touch your primary. What you're doing is just playing with your standby database, just leveraging all the smart features that flashback gives you on the standby database, right? And probably if you are not using it, start using it, and it will be of a great help. You may not be required, for next 6 months, one year, maybe 2 years, 5 years, but you never know when a human can make a mistake. You have to be ready for that. Okay, so that was pretty much on the technical side of this presentation, where I tried to just include all the features and all the technical details, or the small things that you may take care, or that can help you in your decision making while deciding for the flashback. Now I'll go to some real-time issues or resolutions that are normally associated with standby, or that those are basically seen by me in my environment. Those are very common, and you may also have seen, but that is worth mentioning here. So we have talked, or we have seen in all these slides, the most important thing that is going to standby is the redo thing, and that's the only thing that is basically being transported from primary to standby, that is redo. And over top of that, if that is not a sync method of transporting redo, you will end up creating archive log files, and your standby would be getting synced in with primary using archive log files. So this is something that I have seen very common in my environment, that because of network delays sometime, means we do have our primary and standby geographically quite apart, and sometimes we do get some network glitches or network disconnects that can range from few minutes to maybe from 5 minutes to 30 minutes or 45 minutes. In that case, it is impossible for LNS to really keep the sync method going, so it has to fall back to the archive method. So in that case, you can end up missing some sort of archive log on the standby. So what can be done? So if you have a situation where archive log on standby is missing, so ideally standby setup, in a standard standby setup, your RFS process should automatically detect that log gap, and detect that, okay, this particular archive log or archive logs are missing on the standby, and will basically request the archival process on the primary to send those missing logs, right? But that is an ideal situation, and in 8 out of 10 times it should work fine. But there would be a situation where you got this network disconnect between primary and standby, and that file got missed, and at the same time you have a backup running on the primary side to take archive log backups and delete the inputs, right? So in that case, while RFS is requesting for the archive log file, but archival process will not find that archive log file, that particular archive log on the location. So what you can do is you can always restore that particular archive from the RMAN on the primary. So once that archive is restored on the primary, you don't have to do anything because RFS is continuously, checking with archive process on the primary if that file is available. So as soon as that file become available, that would be sent automatically to the standby. In case that file is not sent, you can actually manually send that file to the standby and do a register of that particular log file. And the second common thing that you will see is, you add a data file in a primary and it shows as a missing on standby. Means if you query that read on a data file, you'll see the name of the file is something missing, right? And that's a possible cause in a case where you do not have your standby file management parameter set to auto on the standby side, right? And the person who added that didn't know that he just added the file on primary without realizing what would be the impact on the standby side. So if you have this standby file management set to auto, you can safely add files to the primary, and depending upon your DB convert parameters on the standby, that file will automatically be created on the desired location, right? So in case you end up having a missing file, so what you have to do is you have to manually rename that file to a correct location and name using alter database command, right? You all are aware of that. Then that's again a huge problem for in few of the environments is huge log gap. So in the first point we mentioned about a missing archive log. So when I mentioned about missing archive log, it can be one archive or two or maximum 5, let's say, right? But what if like you have a huge log gap, and for instance, like in one of our environment, like where we are generating 600 gigs of archive logs daily, right? And in a peak time you end up having 30 to 40 to 50 logs, 2 GB each, generated, and you have standby side down for the maintenance, and you end up having 6 to 7 hours of lag from the primary. So you cannot basically rely on automatic log detection and RFS requesting and archive giving you all those logs, because that would be really slow, right? To send up at least 150 gigs or 200 gigs of archive log of that's a huge gap that you have to manage, and sometimes it is more than that. So you do have multiple options. So one of the very basic option that you can do is during the time when the standby side got down and the time the standby side got up, so all the backups of archive logs that are taken on the primary side, you can simply ship those archive log backups to your standby side, and using RMAN, simply you have to do is register those backups and do a recover database command, right? So all those archives would be applied, all those changes during that shutdown of your primary site would be applied using this recover database command, using the backups that you have shipped. Or if you can't do that, then you have another option, that is incremental backup and recover. So what it gives you is you have to find until which SCN number your standby database is. You have to find the current state of your standby database using the SCN number, and then you have to go back to your primary and take an incremental backup starting from that SCN number. So once you do that, you have to copy that backup over to standby and do a recover of database, right? So it will be using incremental backup and would be applying only the changes which are made after that SCN number. So these two techniques we do use, and we have to use normally during the days when we do have operating system maintenance and our whole non-prod stack, which includes standby databases, are down, and we do have to cater for at least 12 hours or 15 hours of log gap. That is not possible through automatic process of RFS. This is a huge help to us. And then there is a primary database hunt problem. So it is more of an operational problem. So if you are a really proactive DBA, so this problem you should not be getting that. But as I said, like, we are humans and we tend to make mistakes, so this can happen as well. So this problem is basically attached or associated with the third point as well, where your standby is down, and on the primary you have archives being generated, and you are taking backups, but in the RMAN you have mentioned your deletion policy to wait for apply on standby, right? In that case, RMAN will still back up the archive logs, but it will not delete the archive logs. And if you are not well aware or proactive to check the space left on the archive log, which you should be, or you should be getting some sort of alerts generated through your scripts or through OEM if you have that, you should not end up in this situation. But in case you have your archive log destination filled 100%, what will happen is your primary database will get hung, and you'll not be able to do any of the operations, and whatever application you are catering to using this database would be coming to a standstill. Your database will be still running, but in a hung mode. So the only the solution at that time would be either you have some alternate location for your archive log, right? That are reactive solutions to that, or you move those archive logs to somewhere else. Again, this is also an reactive. But if you want to be a proactive in that case, what I normally do is I basically have this archive log deletion policy set to none, right? Earlier it was set to apply on standby, but I do have a sort of belief or confidence in my backup policies. And since we have a sound backups on the primary side, I can still afford to delete the archive logs on primary without being applied on standby. I normally use to ship archive log backups from primary to standby to recover the standby in case of huge log gap. So these are the issues which can actually impact you or your environment while you are running a Dataguard setup. And then there are some freebies as well, which are obviously associated with your standby databases only. So one of the key feature with standby database is that means if you have a very busy sort of primary database, and we all know that if we run any backup, let's say incremental backup as well, it does have some impact on the some overhead on the database, whether it is overhead on the memory components, or it is overhead on the IO being used, or on the CPU being used, but it will have some sort of overhead on the primary. So in case you can't afford that, you can safely rely on the backups that you can take on the standby. So if you are taking full backups or incremental backups, or you are utilizing your backup policies on the standby, they are as good as if you take the same policy, or if you run the same policy, or if you take the same backup on primary. So you can simply feel relaxed, or sit relaxed if you are running a backup on standby without actually impacting or putting any overhead on the primary side. So see, with standby you can do have full and incremental backups. So it all depends upon you. Again, so this is the second point is really important, at least for me where I'm working. So we do have SMEs and developers working on continuously working on those applications for which we have the databases. And since there's no other or no best option than the real data that you have in primary to work on. So there are cases when you have users facing some issue, and developers have to work immediately to fix some issues, or they need to have database with real data for a longer duration, let's say 24 hours. So what standby database can give you is an ability to use the standby backups to create the clone databases, right? So how efficiently you use those, it all depends upon you and the setup you work in. For example, let's say in my case, I use we do have a 1.5 terabytes and 2 terabytes of databases, and we use backups and physical backups of standby to clone our other databases, and that in a span of 15 minutes or something, using some SAN features and SAN functionality. So, but the real point is, because I have the backups running on the standby, I'm able to do that. And that's the extra functionality I have it on my standby side. Then we discussed it earlier, like if you have your standby database running in read-only mode, you can safely point or run few processes or reporting processes on the standby site as well. So in that case, your standby database can easily and safely run as a reporting database for you without actually putting the overhead of those reports on the primary. And I have seen that if those reports specifically coming from BI or any other reporting tool, those queries are really CPU intensive. So in case you want to save that part, you can easily run that on your standby site. So apart from that, issue and fix testing. And if you have immediate issue needs to be fixed, you need to apply some sort of fixes, or you want to try fixes, you can safely convert your physical standby database to snapshot standby database, which do not take more than 5 minutes to convert. Do all your testing, and you can safely roll it back to the state from where you converted that. So that is something is being really used extensively by developers and SMEs while they are working on user issues without actually creating any new database. That's the best part of this one. Uh, there's one more option that I'm still working on. I haven't tested that, so I just included this in my presentation. So if someone may have tested this thing, can personally ping me and confirm this. Is like you can actually upgrade your primary with your standby intact. So what happens is, let's say in case you have a 2 terabyte database, for a few of them this must be a small database, but depending upon the environment that I work in and the resources that we have, that's a pretty big, right? And so I have a 2 terabyte database, primary database. In case we have to do an upgrade that we do normally, right? I have to always rebuild my standby database, because that wasn't, let's say if I am going from 12.1.01 to 12.2, right? Or 12.1.2 to 12.2 or something, right? So I have to upgrade my standby. So what we have been trying to do is, in this approach, we will be installing our 12.1.2 binaries on both primary as well as on standby, and shut down once we are ready with the upgrade. We'll shut down both primary and standby databases. We will start the standby database using the new binaries 12.1.2 and run the start the standby database in upgrade mode while it is still connected to primary database. So since it is being connected to primary database and standby uses redo only to recover the things or to apply the changes which are done on primary, once we run the upgrade command on primary, those changes will automatically be applied on the 12.1.2 on standby as well. So, but I have mentioned that thing in red that still need to be tested. So I'm still haven't tested it fully. We are still doing that. But if this is being done, that would be a huge sort of success, or huge 1+1 from my side, that I don't have to basically recreate any of the standby database in case we are doing an upgrade on the primary, right? And this can save a lot of time for all of us. And then there is a one quick tip, and that is basically related to redo compression. So as I said, like on few of our databases, we do have huge archive logs generation, let's say 500 GB or 600 GB per day. And with databases or standby databases being geographically apart, ranging from more than 500 miles or something, right? And the network has some limitations and will always have some limitations if we think practically. So one option that Oracle gives us is redo compression. So what it does is, like, it will, before LNS actually send the data across to standby site, it will basically compress your redo so that the amount of the size of the total redo that you are sending over the network would be less. And that is basically true, or would be really helpful for the slow networks or the networks with a really limited bandwidth. But the important part is, yes, it's a Oracle Dataguard feature, but the red thing is it requires additional license. So you need to have that advanced compression option license with you to use this redo compression. So what, as an organization has to decide is whether it is worth having that or not. So while your organization is still deciding on that, or they have decided not to use that, I do have a free option, or that is something that we are using in our case, and it has helped a lot, is network compression. So what basically you have to do is you have to create a SSH tunnel between your primary and your standby side, and over that tunnel you have to do your compression. So it is after, once LNS has read the redo and sent over the Oracle net, that is the point where the compression will take place in the network. So here I am not doing any favor to LNS, or I am not doing any favor to RFS. Basically what I am doing is, since I have a bottleneck, a network bottleneck, and I can't or the organization can't have an additional license, at least at this moment, you can still have SSH tunnel created. And the funny and the tricky the fun part is, you have to have these additional options to be listed down in the command, and the option to compress is -c, right? So what it does is, let's say I have a standby site named standby.site.com, right? And what I will do is, I am saying I am doing SSH and creating a tunnel, and the port for my tunnel would be 9022, and it would be basically connecting to standby.site.com and would be replicating 1521 as a port, right? So once you do that, right, this SSH will start using a gzip algorithm to compress your redo over the network. And it is, yes, it is useful for slow networks. But one thing that you have to keep in mind here is, like, let's say if in my case, if I'm using 9022 port, you have to go back to your tnsnames.ora file on your primary database, right, and change the host to localhost and port to 9022. So since you are mentioning that all the traffic that is being sent over 1521 will be rerouted through 9022, and whatever is being sent over 1521 will be rerouted to 9022 and will be compressed, that has to be mentioned in TNS. If you do not mention that, your archive or your redo stream would be sent over the standard thing. It will not be compressed. It will be a standard process that redo would be following. And yes, it is really useful for slow networks, and it has really been useful in my case at least. So that's it from my side. So thanks for your attention. So I'll just have Aman take over from now, and I'll wait if you have any questions, and Aman can just ping me or message me.
Thanks, Navneet. That was a very informative session, and that was actually, I think, going to be very useful for all the attendees. Let me just quickly check out for the questions.
Sure.
Okay. So as such, I think we didn't get any questions from the attendees, but we have got some accolades from the people. Our good friend Amardeep is mentioning good stuff. So lots of good feedback actually. So I think that's pretty much there. Not exactly any questions actually.
Thank you for that.
I
so
think it is.
In case like anyone has any question and later they want to contact me, so you can still get back to us on our WhatsApp group, or simply ping me or contact me over my email ID, and I would be happy to answer that if I can.
Yeah, I think that is going to be okay. So we have got a few questions coming up from, we have got some questions coming up from Uday and Jamal. Okay, so what happens to the primary if FARSec instance goes down or unable to write to the standby redo logs? That is one question.
Can I answer that, or we need to answer all the questions?
Yeah, you can actually answer that. I'll follow up the other questions later on.
So in case of that, so that's a good question, and I actually included that in my slides as well. So although we do have a fast sync directly connected to our primary database, but we do have a link or a network link that connects primary to standby as well. Means there is a direct link between primary and standby. So in case my fast sync goes down, my primary will basically fall back to a direct connection to a standby using maximum performance mode. So you'll no longer be into a maximum protection mode if you are there, or if you were there with fast sync, you will be falling back to maximum performance mode, and primary would be talking directly to standby, skipping my fast sync. So once fast sync comes back, then it will fall back to the original setup that you have.
So just to summarize that if the FarSync instance is going to go down or it is not able to write through the standby logs, then FarSync goes out of the picture. Am I correct?
Yes.
Okay. Okay, thanks for that. So now we take the second question from Uday, that can we use physical standby open read only as reporting? In that case, there will be at least DBA underscore hist tables need to be updated in system data files.
Yes, that is true, and that is true only with active data guard feature if it is enabled. So that's why like Oracle is charging us extra for that.
Right, right, okay. And Jamal is saying Oracle, we can find primary instance due to maximum mode. Can we have same unique name?
What is that? I didn't
Well,
get it.
I believe the answer is going to be a no. I mean, uh, Oracle, we can find
You need
primary
to have
instance
a
due to
DB
maximum
unique
mode.
name as a different, and you still have the DB name as the same, but unique name is always
Yeah,
different.
DB name has to be same because anyways the DB is being replicated, so it has to be same. The DB unique name is going to be different. Can we have unique name as primary and standby? If yes, then how?
Can we
I
have?
believe you just answered it. I think the question is, can we have unique name as primary and standby? If yes, then how? So I think DB unique name should actually answer the question for Jamal.
Yeah. So it's the answer is no.
Oh, okay, okay. Can we have the unique names as primary and standby?
Means
Okay,
I believe
so the
he's
answer is
asking about the same. Means if we have a same name, so the answer is no to that.
yeah. If it is same name, then no. That but of course it's unique, so it has to be unique. That means distinct across all the sites. So it has to be distinct.
Mhm.
Okay, so I think that summarizes the questions. I think that's pretty much about it. We got few more accolades coming up from Rajneesh, Shankar, and even from Uday. Giving you a thanks and uh, you know uh, having a very good feedback on the session. Okay, so I think that should be all, Navneet. I think that is going to be okay. One more question coming up from Jay Khare. What happens if we put logwriter sync affirm mode if protection mode is maximum performance?
Well, in that
I'll
case,
repeat the question.
so in that case, it would not allow that, right? That is how in maximum performance it cannot run in sync. So once you are putting that in sync, you are asking for the feedback from the RFS. You are asking for the acknowledgement from the RFS. You can't do that. So if you have to put sync with affirm, it has to be in maximum availability mode, not even maximum protection or maximum performance. It has to be in maximum availability mode.
Okay, so I think that should be the answer. Probably Jay was looking for. Okay, yeah, I think that's pretty much it. Any more questions, anyone? In case you are having any questions, we have Navneet right here with us, so he can give the answer, immediately. Otherwise, it's going to be the same process of email and, then waiting and all. So, in case you have any questions, please put them forward so that we can ask Navneet right away. We'll wait for about 2 minutes. It's 12:38 local time, so we'll wait for 2 minutes. At 12:40, we'll probably close, the session. So in the meanwhile, Navneet, what do you think about the new 12C data guard features? Like, which features of the 12C version? Okay, so we got a new question coming up. In that case, how to ensure maximum protection with FarSync in place? I think this is coming up from Uday again. So
Okay.
it is related to the previous question that if the FarSync instance is not available, cannot write to the standby log, then what is going to be the impact on, or how you going to actually provide the maximum protection?
So if okay, so that's a good question. That's a nice catch actually. So in case you are running your fasting instance in maximum protection mode, right, with primary, in that case it will not fall back to a standby because you want that maximum protection. In a case where you have a maximum availability mode setup or maximum performance mode, then in that case it would fall back. Otherwise, in case of maximum protection, it would be a standard process where it has to stop. It has to shut down the primary for that until you manually in case of failure, until you do a manual change to your setup, means you put up an alternate location for your primary to standby, and put alternate location as your actual standby, where it can actually start doing a maximum protection mode. In case of maximum availability and maximum performance mode, it can actually fall back directly to standby. In case of maximum protection, it can't.
Okay. Can we have far sync on rack with multiple instances?
Yes.
This is from
Yes.
Jamal.
Yes, we can have that. So in that case, so it has like it's up to you. You have to decide whether your fast sync has to be also in a rack. Let's say you have a 2-node rack or a 3-node rack. It doesn't mean that you need to have a 3-node, 3 instances for the fast sync as well, or in fact like 3 instances for the standby as well. So you can have that, but even if you have a 1 fast sync and 3 standby, it will work for you. So means what we
Okay.
have to see is we have means what we have to understand, the purpose of fast sync is the communication between primary and the standby. The fast sync standby needs to be as fast as possible, right? And there needs to be no delay in case you are using maximum protection mode, right? So in case you have a single instance, that will really work for you, and that can accept logs for let's say for 3-node rack. You need to have threads enabled for 1, 2, and 3 on your fasting. That's it.
Okay. All right. I believe that should answer the question of Jamal. Okay, everyone. So we have crossed that 2-minute time limit that we have mentioned. So last chance. Any questions? Otherwise, we will close. Thanks, Uday. Thanks for asking such great questions, and Jamal and everyone as well. Okay. I believe no. Otherwise, we'll take the any subsequent questions, Navneet. I think we'll probably take offline, or you can actually take them personally in your email or Twitter or other social media channels that you actually have or we actually have in our chapter, right?
Sure.
So I think probably it's best to close it right now. So thanks everyone one more time to spend a good nearly 2 hours of your weekend with us in this particular session. And of course, we're going to be doing the same kind of sessions again and again. And again, in case you want to present, do send us a session abstract. In case it is going to be useful, it sounds good, we definitely go ahead and we'll publish it and organize it. So we organize monthly events. We are going to be organizing very soon in this month, most likely in Delhi. The details will be following up soon. So do come to the events, do attend these kind of webinars, and most importantly, do come and present, right? So that's basically going to be the idea of these particular meetups are. Okay, so with that note, thanks a lot, Navneet, for giving this excellent session, and I believe we shall close now.
Thanks everybody for connecting for today's webinar, and thanks Aman for hosting that. Thank you.
Thank you.